Okay, I am still not feeling very well at all. I am making this video Wednesday afternoon just in case I'm not there Thursday. Even if I am there Thursday, I might just have you watch this video because I don't have the energy to teach an entire class, but I am doing the best I can. And you guys have already learned everything that's going to be on the test if we include what I'm about to do a warm up on. So this is definitely on the test. So find some space on a piece of paper to copy this down. So remember, on your test, you don't get a calculator, but relative frequency histogram is part of your essential skill. So to make that work on this test, what we've done or will do is we will fill in this side of the table for you. But I just want you to remember how we got that. If we added these all up, there's 55 pieces of data here. So we did 7 divided by 55, 10 divided by 55, 20 divided by 55, right? 8 divided by 55 to get all those numbers. Excuse me. So this is what you'll be given. You'll also be given graph paper, but obviously I need to draw my own for right now. So that was terrible. I was there to teach you regular histograms, and I mentioned this on the regular histogram day. A lot of your points, like half of your points, come from labeling the axes. And if you aren't labeling the axes on the things that you're turning in, I'm not giving you full credit. Because on test day, I'm not going to give you full credit. So this problem is talking about ages. So the bottom is ages. The bin widths have already been set up for me. They're counting by fives. 0, 5. I didn't need to go to 35, but set up the bin widths to match what they give you. We were asked to do a relative frequency histogram. This column is labeled relative frequency. Your y-axis needs to say relative frequency. Relative frequency counts by decimals. So for these are all, they only go to 36. So if I go 2 and call it 0.1, 2 and call it 0.2, 2 and call it 0.3, 2 and call it 0.4. This is like 2 out of 4 points, and I haven't really done anything. Don't forget to label your axes. Then I'm just going to start filling in the bars and writing the numbers on top. 0.13. The middle one is 0.15, so a little less. 0.18, so closer to 0.2. 3.6, a little more than 3.5. 1.5 is right in the middle. Barely more than 1. A little less than 1. This is a fully complete relative frequency histogram. But we will probably ask you questions. What percent are older than 20? See if you can answer that question. Also, what percent are younger than 10? So older than 20, here's 20. These two numbers added up. Younger than 10, here's 10. These two numbers added up. Oops. And they want it as a percent, so 18%. Line them up if you need to do this by hand without a calculator. That's 11. Carry the 1 is 3.31, so 31%. This is an essential skill, labeling your axes. I'm going to tell you and take off points over and over and over again. Okay, then page 7. A percentile indicates the percentage of scores that are below the score in question. So when you do SAT tests or any sort of standardized test, they usually send you your percentile in the mail or with your score. So if you're in the 80th percentile, 80% of the people scored lower than you, or you scored better than 80% of the people, however you want to word it. So percentile is the number, percentage below your score. So normal probability density function. This is something that I have to teach you, but it's not going to be on the test. So I need you to not panic as I go through this stuff. Teaching it online isn't the most ideal situation, but we're going to do what we can do. So the first thing I need you to know, you can read through this on your own, obviously, but the mean, which is just another word for average, they use this mu symbol. It looks like a cursive U, but it's the Greek letter mu. And then standard deviation, another statistical term, they use this lowercase sigma, which looks like a little circle with a little curly hat on top of it. That's sigma. So we need to know this for the test. Mean is mu, standard deviation is sigma. Also, you need to know, well, let's talk about what's happening here. So what's happening is we have a normal curve. This is called a normal bell-shaped curve. So sometimes when we do, like I said, standardized testing, when we make our histogram, right? So here's our histogram over here. This clearly was not really bell-shaped, but some things that are standardized, when you draw your histograms, the little bars make a perfect bell shape. They are normally distributed, is what that's called. And in the middle is where mu, the mean, is. When I asked you on this problem to find what percent are older than 20, we had to find the bars and add them together. But when things are normally distributed, if you know where that number is, like this problem is doing 14, less than 14, there is a button in the calculator that'll find the area of that shaded curve for you. It will add up all those little bars for you because they are normally distributed. So it's really handy for things that are normally distributed. In order to make your calculator do that, you need to know a couple things. If the problem is talking about less than, what percentage of scores are less than 200 or whatever, we are going to use the calculator's equivalent of infinity because the bell curve goes infinitely in both directions. So even though you can't score negative infinity on a test, we're going to pretend you can. And the way the calculator does negative infinity is negative 10 to the 99th power. If the problem says greater than, how many people scored greater than 200? Even though you can't score 500 on a test that only goes 300, we're going to pretend you can, and we're going to use positive infinity. In a calculator, positive infinity is 10 to the 99th. So we need to know these things. Then we need to know how we're going to write it. So here's a question over here. The normal PDF at left represents miles per day ran by an athlete. Sorry, I'm reading this box right here. They give you the mean. The mean is 15. And they give you the standard deviation. Standard deviation is 2.5. They have to give you those things. Mu is 15. Sigma is 2.5. They want to know the area under the curve, the probability that they run less than 14 miles per day. So less than, remember what I said about less than? So what we're going to do is we're going to do normal CDF. This is a button in your calculator. I'll show you that later. And it will always be minimum, maximum, mu, sigma. These are given in the problem somewhere. And then these come from reading the problem. So over here, they already did it for us. Normal CDF. Less than means negative infinity. Even though you can't run negative infinity miles, we're going to pretend you can for these types of problems. And we're going to do normal CDF, negative 10 to the 99th, comma. The maximum is what they gave me. They want less than 14. So 14 is the max. Comma, mu is 15, and sigma is 2.5. When you type it into your calculator, you get this decimal, and you move it 2 places to the right to make it a percentage. So there are some problems for us to do on the next page. Here's all that out, written out again. If you can't find the buttons on your calculator later, you can use this page to help you. At the bottom, the Michelin Defender tire has a mean life, that's mu, of 60,000 miles, with a standard deviation That's sigma of 3,000. Suppose the distribution is normal. It has to be, and find each of the things. It should say probability with a pen that a random tire will last 65,000 miles or less. So these are always normal CDF. And since you won't have a calculator on your test, this is what I expect you to write. Normal CDF, parentheses. First two numbers are our min and max. This says will last 65,000 miles or less. Or less means your minimum is negative infinity, negative 10 to the 99th, comma. The maximum is the number they gave me, 65,000, comma. Mu comes next, 60,000 given in the problem, comma, and standard deviation is last. Once you type this into a calculator, you will get 0.952, which is 95.2%. Okay, now I'm going to attempt to show you how to do this in a calculator. So the problem is that I have to switch to camera and try to hold it steady and try to show you the calculator at the same time. So feel free to borrow one of my graphing calculators if you want to know how to type this into a calculator. Okay, so this is what your calculator looks like. You want to just make sure you turn it on if you've never used one. That's down at the bottom. We are doing distribution. See in blue right here? It says distribution right above the vars button. Because it's in blue, to get there, I press second, distribution. We are doing normal CDF, so number 2. You can either press the button number 2 or you can scroll down and press enter. Most of the calculators will bring this up. So let me bring up what we were doing. Sorry. Okay, sorry, I didn't have my numbers that we wrote down. So you have it right in front of you, right? Normal CDF, negative 10 to the 99. So the negative button is down here, this little minus sign. If you use subtract, it's going to say you have an error. So negative 10. This is the caret symbol, the exponent button. 99. Enter will take you to the next slide. The upper bound, we said the upper for the problem was 65,000. Enter will take you to the next line. Mu, the mean for the problem was 60,000. Enter will take you to the next line. Sigma, the standard deviation for the problem was 3,000. You press enter again, and then you press enter again, and it'll put it on your calculator screen. And you'll notice this is the way we've been writing it down. Normal CDF, negative 10 to the 99, comma, 65,000, comma, 60,000, comma, 3,000. Press enter it again, and it'll do the problem. Move the decimal twice, and you get your percentage. So let's figure out what B would be. So it's still the same stuff. 60,000 is the mean. 3,000 is the standard deviation. It's always going to be a normal CDF problem. That's all we do. 65,000 miles or more. 65,000 is the minimum. Or more means to infinity, even though your tire's not going to last forever. For these problems, we pretend that it could go to infinity. Positive 10 to the 99th. 60,000 is still the mean, and 3,000 is still the standard deviation. I'm going to write down the answer so that you have it for later. 0.048. Move the decimal twice, and you get 4.8%. I'll show it in the calculator in a second. C, between 52 and 62. So normal CDF. And again, on test day, you would just stop here. This would be what you write, and you'd be done. Between 52 and 62. So 52,000 is the smaller number. 62,000 is the bigger number. 60,000 is still the mean, and 3,000 is still the standard deviation. Okay, let's get those out of our calculator. Okay, so I'm back on my home screen. This was the answer to our last problem. Second distribution takes us there. Normal CDF, number 2. You just type over these numbers. So on B, it was 65,000. Enter. And then our upper was positive infinity, 10 to the 99. Enter. These numbers stay the same, so I just press enter on top of them, and then I press enter on the home screen, and then I press enter again. That's the answer I had given you on paper. Move the decimal twice to make it a percentage. Do C. 52,000 to 62,000. Those numbers stay the same. That's the answer I gave you on paper. So this is going to be the last time I show you on the calculator, but I do expect you to type it in and get your answers while you're doing your assignment. Okay, next page. Half-liter soda bottles are filled with Coca-Cola at the bottling plant. The equipment used to fill the bottles is not capable of putting exactly 500 milliliters. So it's adjusted so that the amount of Coke placed in the bottles follows a normal distribution with a mean of 502 and a standard deviation of 1.8. What proportion of the bottles? So what's the probability? We'll have more than 502. More than 502. Normal CDF. More than 502 means 502 is the minimum. Positive 10 to the infinity. Positive infinity, which is 10 to the 99. Even though it's not possible to fill a bottle with infinite Coke, we still use that in the problem. The mean was given and the standard deviation was given. Type it into your calculator, move the decimal twice, and you're going to get 50%. 50% because that is the mean. The mean is in the middle of your... That's not a good bell curve. The mean is in the middle of your bell curve. So more than is going to be half. So would less than, by the way. Be between 500 and 502. 500 is the minimum. 502 is the maximum. The mean and standard deviation have not changed. Type it in, move the decimal twice. You should just be checking these on your own. Underfilled, less than 500. Negative infinity, negative 10 to the 99. 500. Okay, now we get percentile questions. Remember, percentile was the first thing I told you today. Percentile is the percent of scores less than yours. So that means we're doing normal CDF. Percent less than 503. So negative 10 to the 99. 503 mean standard deviation. When you do that, you get 0.7107. When it's asking for a percentile and you move it twice, you round it to the closest whole percentile. So 71st percentile is how we would answer this one. Not 71.07%. Percentile needs to be written as a whole number. What happened here? Percentile. Okay, let's try E. Okay, last one. Pause the video. I'm going to put all my answers up at once. See if you can do number 3. Okay, so average is the same thing as mean. So they gave you the mean. They gave you the standard deviation. At least 95 means 95 or bigger. Between. And then percentile means less than. And we write it as a whole number percentile. Okay, yes, that is it for today. So you guys have a worksheet to do. And remember, if this was a sub day, you need to upload these notes before midnight. If you have a substitute, you have to do the thing that's in class and get it submitted that day. I hope you guys are doing good.